Question number 10. You are asking to use a graph paper to answer this question. So, table 10 shows the values of two variables x and y obtained from an experiment. Variable x and y are related by the equation y equal to PE exponential to the power of 5q square root x, where P and Q are constants. E is a natural number base, right? E is a natural log number. Okay, today we are going to solve the linear law using graph. But this graph is not the normal log base 10, it's ln. So first of all, we have to construct a table for the value of square root x or sub x and ln y. So now let's get ready with the calculator and press. We have to create a new table whereby we need to have the sub x and also ln y, right? So let's create the table, and then we will draw the graph based on the new table. So if you press the calculator, I'm going to create a new table here, let's say. So you have to label new axis sub x and ln y. So you press the calculator, square root 1, right? Now you press square root 1, you get 1.00, right? Okay, if you press your calculator square root for 2, you get 1.41, right? For 1, you have to use 2 decimal. And 2.5, if you press, you get 1.58, right? 3.0, you get 1.73, right? Square root 3.0. Square root 4, of course, is 2.00. And square root 7.3, you will get 2.70. Now we need to press the ln. The calculator comes with a ln, ln. So let's write down the ln. Okay, for ln, ln 3.5 is 1.25. Ln 6.02, you get 1.80, right? Ln 7, you will get 1.95. Ln 8.15, you get 2.10. And then ln 10.79, you get 2.38. And then ln 23, you got 3.14. Okay, we need to plot the graph based on the new table that we just construct, square root x and ln y. Now we have to follow the scale given. Plot ln y against square root x using the scale of 2 cm to 0.5 unit on both axes, square root x and ln y axis. Hence, draw the line of best fit. So now I'm going to teach you how to read carefully the gradient and intercept. Before we read the gradient intercept, we must make sure the line is line of best fit. So I'm going to explain to you what is line of best fit. Alright, so please stay focused to the definition of line of best fit. After that, we will use the gradient and the intercept to solve the constant. Now, how to solve the constant is we have to start from the nonlinear equation, which is this one. We are going to start from the nonlinear equation. Y equal to P exponential 5q square root x. So I'm going to show you how how we will derive or we will come up with a linear equation. P equal to exponential, right? Exponential. The power is 5q square root x. Okay, y equal to, the equation is y equal to p, and then exponential. Okay, let's copy down. 5q square root x, alright. 5q square root x, this is the power. So first of all, because we have ln y, so we take ln. Ln means log with the base e. You can write like this. If you want to write like this, log e y equal to log e p times e 5q power x. Good. You can see the base there is log base e. Log base ey is ln y. So now we have a multiply here. So what we need to do is we need to plus. Okay, but when we plus, we must make sure we have ln plus with the same base. Here is e 5q to the power x, right? So instead of write log e all the time, sometimes we feel very tired, we just write short form ln y equal to ln p plus the power. This is a power, right? This is a power. You must shift to in front. And what is ln ee? Is 1. So we will write 5q third x or square root x. Now we almost got the big Y, which is ln y. And then 5q is a gradient, right? M. And then this is a big X plus ln p. Got it? So this is a big Y. This is a M. Okay, this is a big X. This is a C. Okay, so we will find the intercept, y-intercept from the graph. And then we will compare with the ln p. Okay, and we will find the gradient from the graph also, using the best 2 points on the line. So we will equate with the gradient from the graph. This one will equate from the intercept from the graph. So if you read the y-intercept, you will get 0.1, I think. So you won't read so accurate, alright, because this is a graph paper. Gradient, if you read carefully, you will get the gradient is 1.16. Alright, this is 1.16. So we are going to do calculation based on that. So we will write 5q is a gradient is equal to 1.16. You have to show y equal to you have to show your y-intercept. You have to show your gradient. Use y2 minus y1, right, over x2 minus x1. And then we can solve the q. Q is 0.232, right? Alright, make sure you find the gradient using the point on the line. After that, we want to solve the intercept, right? Ln p equal to intercept, which is 0.1. Okay, so your p is exponential 0.1. So the p is, you can just write answer. You can press your calculator, shift ln, right? Shift ln. If you are using calculator new one, you can just shift ln 0.1, and your answer is 1.10. Always write your answer in 4 significant figure, 1.105. Alright, that is the right answer. For the constant p, we actually try to solve the constant for the linear law by using the gradient and the y-intercept from the line of best fit. Alright, that's all about solving the constant using the gradient and y-intercept from the lines of best fit. Here then, we still got one more part or not. Normally the last part they will ask you something to do with the point. I don't think so, right? That's all. Okay, then bye bye, have a nice day. So now let's erase the red color line. You can use a ruler to adjust when you do. Now I'm showing you the concept, okay, the concept. So since the line is fit, so we can read the intercept. So the intercept is here. Let's read out the intercept. We want the y-intercept here. This is the point that we want to read. Y-intercept is at 0 point. This is a y-intercept. Let me enlarge it. Okay, y-intercept is at 0.0856. Now for the graph that you drawn, you cannot read until 0.08 something, right? You can only read as 0.1. That is the best y-intercept that you can read. So please use a 0.1 as a y-intercept. See, the red color dot or point is out of the line, and there's one red on top of the line, above the line, and there's one red point below the line, so it's balanced. And the line must pass through as many points as possible. Okay, so this is a very fit line. So if you draw just now, it is not the line of best fit. Okay, because the number of a point below the line is not the same with the number of points above the line. Is this a line of best fit? The answer is yes, right? It passes through one point B above the line, point F below the line. So this is line of best fit. This line is not line of best fit. Now you see, the line that is fit, it must have number of points that not on the line will be the same with the number of points above and below the line. So here you can see that there are so many points not on the line, isn't it? And there are no point below the line. This is a very beautiful line because it's line of best fit. I just show you the y-intercept again. Okay, this is the most beautiful line that we want. So let's make it bigger a bit with the y-intercept. Okay, this is the best line that we call as the line of best fit. That's all my sharing. Till then, bye bye and have a nice day.